I'm Jackie. This week we're going to evaluate this integral using partial fractions. So let's set that up. So the whole point of partial fractions is to break up this fraction into different pieces that we can integrate. So we'll want to do this. Notice that it's repeated. You have to do it when it's a squared term like this. Okay, so now we just need to cross multiply. So we're going to get 2 equals so it's not a squared term over here because one of them will cancel with what's underneath, right? So if I multiply this and this to A, one of these is going to cancel. Similarly for B, right? And for C. Okay, so now we just need to multiply everything out and get different equations. Okay, so now once we get to this point, we need to combine terms. So let's start with the x squared terms. So we have one here, and one here, and none over here. So that's going to be 0 equals a plus c. Our next equation, let's look at the x terms. That's here and here. And again, we have none over here, so that's 0 equals b minus 2c. So our last one has to do with the constants. So I'm going to circle those. We have one here, here, and here. So that then means we have 2 equals negative a plus b plus c. So now we have a system of 3 equations and 3 unknowns, so we can easily solve for each value. If we do that, we get that a equals negative 1/2, b equals 1, and c equals 1/2. Okay, so now that we have these values, we can plug them in up here and solve the original integral. So let's do that over here. So we'll have the integral of a is negative 1/2, so x minus 1. Plus our b term, it was 1, so it's just 1 over x minus 1 squared. Plus our c term, which is 1/2 of this. So now obviously this is an integral we can solve. So that's quite easy. We just do it each section. And so this is our final answer, this. So obviously, using partial fractions makes the integration easier and doable.